This is chapter 4, set E, problem 5. And we're also going to do problem 6 as well. So if we want to find the average of the data set, what we do for that is we add up all of our numbers. So like 1 plus 3, plus 4, plus 5, plus 7, and divide by how many there are. It looks like there are 5 of them. So if I add that up and divide, I should get 4. Now, the problem told me to find the average, find the deviations from the mean, and find the standard deviation. So let's go through like we did in our guided lectures and make a nice little table and everything so I can find, as part of finding the standard deviation, it's easier if you use this table to first find the deviations. So I'll write down each data value, 1, 3, 4, 5, and 7. And then see how far it is from the average. So I'll do 1 minus 4, so do the value minus the average, gives me negative 3. And 3 minus 4 gives me negative 1. And 4 minus 4 equals 0. 5 minus 4 equals 1. 7 minus 4 equals 3. So I think the textbook told you to find the deviations from the average. That's these numbers right here. Okay, that's how far each one is from the average. If you add them up, remember that will always give you 0 when you add them up. So because we realized it will always give 0, we decided we should square them. So we'll do negative 3 squared, which is 9. Negative 1 squared equals 1. 0 squared equals 0. 1 squared equals 1. 3 squared equals 9. Now, I can add those up. So 9 plus 1 plus 0 plus 1 plus 9. Oh, that should give me 20 again. So now that I have the average, or I've added them, now let's find the average or the mean of the square deviations. So that's where you add them up again, but we've already done that, and divide by how many there are. So there are 5 of them. So if I add them up, we already said it's 20, divided by 5 gives me 4. So that's the average or the mean of the square deviations. It's just a coincidence that it happened before, like the average, complete coincidence, please ignore that. Okay, and then take the square root of the average of the square deviation, so square equals 2. So my SD equals 2. So I found my average, I found my SD. Now doing all that by hand takes a while, but now we're going to try it for another set, and the reason they're having you do it all by hand is they're kind of letting you prove our rules for standard deviation and mean. So now it gave me a different data set, and let's find the average of that. So you add them all up, 6 plus 8 plus 9 plus 10 plus 12, divided by how many there are, there's 5 of them. When you put this into your calculator, make sure you do everything on the top first, whether you have parentheses or doing it in 2 steps. So you should get 45 over 5, which gives me 9. Now let's find the deviations and square them. So write down each of your data values, 6, 8, 9, 10, and 12, and figure out how far they are from the average. So 6 minus 9 gives me negative 3. 8 minus 9 gives me negative 1. 9 minus 9 gives me 0. 10 minus 9 gives me 1. 12 minus 9 gives me 3. If you add those up, you'll know, again, 0, because that's what you always get. And then let's square. So negative 3 squared equals 9, and I'm just going to write them down. If I square each one, I'm going to get 1, 0, 1, 9. And if I add them up, I get 20. So now find the average or mean of the square deviations. So remember, that means you have to add them up and divide by how many there are. So we already added them up. We got 20, and divide by that 5, and you get 4. Now take the square root of those standard deviations. So square root of 4 gives me 2. So my standard deviation equals 2. So I did that for both lists. Now do you notice anything here? You might notice that we got the same standard deviation, but the average was different. So let's come back and look at, for part B, it said look at these two lists. How are they similar? How are they related? Notice 1 and 6, 3 and 8, 9 and, or 4 and 9. It looks like every value they just added 5. So like 1 plus 5 is 6. And then 3 plus 5 is 8. 4 plus 5 is 9. 5 plus 5 is 10. 7 plus 5 is 12. So for part B, what did they do? What's the relationship? So they added 5 to each value. Now our rules that we memorize say if you add the same number to every value, the average should add 5. or you should add 5 to the average. But it says if you add the same value to add the same number to every value, the standard deviation should stay the same. So the reason this problem is in this section is you're kind of proving it to yourself and proving how it works. So did our average just add 5? We went from an average of 4 to an average of 9. It just went up 5. That's just what we said it should do. Now, if you look at the deviations, how far was each value from the average? Because we added 5 to every value, then the average went up 5, but everything else went up 5. So notice the deviations from the average did not change. So that's one of the things the textbook says is the deviations from the average didn't change. All the values were the same amount away from the average. And what that means is then the standard deviation will be exactly the same because all we did is just shift those numbers up. We didn't stretch them out. They're still the same distance from the average, so the standard deviation did not change. So this was just kind of a proof so you can see where those rules come from. Okay, I said this video will include number 6, but I think I'll stop and make a new video for number 6.